Welcome to 3.1 Defining an Acid. You need to look at textbook pages 30 to 31 to help with this video. The lesson objectives for today are to know that a base is a proton acceptor, to know that acid-base equilibria involve the transfer of protons, to know that water is weakly dissociated, and to know that Kw is equal to the concentration of H plus times the concentration of OH minus. So first of all, we'll start off some basics. So when we're talking about acids, we talk about protons. But what is a proton? Well, a hydrogen is one electron and one proton. If you look in the periodic table, you'll see it's got an atomic mass of 1 and an atomic number of 1. So it's got one electron and one proton. It doesn't have any neutrons. So if you have a hydrogen ion, which is a +1 charge, it means the electron's been removed, which means you're just left with a proton. So that's why we call a H plus ion a proton, because that's all it is. There are no electrons, no neutrons, it's just a proton. So why do protons have special properties? To realise why protons are special, you need to think about what you know about atomic structure. And you already know from your atomic radius work in AS that most of the atoms are actually empty space. So you've got a tiny bit in the middle where your protons and neutrons are. And then you've got a vast amount of empty space, and then you've got the electrons whizzing round. So a typical chemical ion is going to have a diameter of about 10 to the minus 15 meters. For a proton, this is only 10 to the minus 10. So sometimes it's difficult to see the factors involved when we have numbers in standard form, but this is a factor of 100,000. So a proton is 100,000 times smaller than a normal ion. And this difference in size leads to the proton having unusual properties. So now we need to talk about classification of acids, and this comes in two parts. The first part is whether an acid is monoprotic, diprotic or triprotic. So you've met the word stems mono, di and tri before. So mono means 1, di means 2 and tri means 3. So protic just refers to the proton. So a monoprotic acid is, as you can imagine, is going to give one ionizable hydrogen atom per molecule. So each one, for example, of HCl is going to give one H+. And there we've got also CH3CO2H, which is ethanoic acid. That's also going to give one H. So both of those are monoprotic. A diprotic acid is one where there's two H+ ions that can be given up. So the most common example of this is H2SO4, which is sulfuric acid. Then triprotic acids have got 3 ionizable hydrogen atoms, and the most common example of this is phosphoric acid, H3PO4. So a diprotic acid ionizes in 2 stages. So here we've got the example of sulfuric acid, or H2SO4. So the first thing it does is lose one H+, and you've got that reversible arrow there, which shows that the process is reversible, and that gives HSO4-. That HSO4- can then lose a second H+, to become SO4-2-. So now we've got the second part of classification of acids, and that's to do with strong or weak, which is something that you would have met at GCSE, but you need to revise here. So a strong acid is almost 100% ionized in solution. So what that means is, if you have, say, 1,000 molecules of HCl, then there'll be 1,000 H+, because all of them have ionized, or become the ions. A weak acid is one where it's only partially ionized. Typically this is less than 1%. So what that means is, say for example ethanoic acid, if you had 1,000 molecules of ethanoic acid, there might only be about 4 H+, so most of them are still the molecule. And it's important not to get mixed up here between concentration and strength, because you could have a strong acid which was really diluted, but it would still be a strong acid. And likewise, you can have a high concentration of a weak acid, but it's still going to be a weak acid. So now we come to the definitions of acids and bases according to Bronsted-Lowry, and that is that an acid is a proton donor and a base is a proton acceptor. And this means that an acid-base reaction is then going to involve proton transfer from the acid to the base. So the acid gives up the proton and it's then accepted by the base. So this simple example here is HCl plus ammonia. So obviously the HCl is the acid and the ammonia is the base, and then you end up with this product, ammonium chloride. One thing you might have not considered before, but you should have done at GCSE a little bit, is that water can act as an acid and a base. So water can lose a proton to become OH-, but it can also accept a proton to become H3O+. So water can act as both an acid and a base. Now the H3O+ is usually called an oxonium ion, but you might see it also written as a hydronium ion or a hydroxonium ion. But normally in our exam specification, it's referred to as oxonium. The OH- you might have come across before is called a hydroxide ion.